All right, today we're doing a kind of health checkup. But our patient, well, it's not a person. It's our entire planet. We're going to diagnose three major conditions that are affecting the very air we all breathe. So, let's start with a bit of a mystery. What in the world connects a massive flood, a really nasty sunburn, and, say, a beautiful old monument that's just crumbling away? It sounds totally random, right? But the answer is incredibly important and very, very real. The answer? It's in the air. Literally, our global atmosphere. This huge envelope of air that we all share doesn't really care about the borders we draw on a map. What happens up there connects every single one of us, linking these seemingly separate problems into one single story. Okay, let's start our checkup with the first diagnosis. Think of this one as the planet running a fever, and it's all driven by something you've definitely heard of, the greenhouse effect. Now, you've got to understand, the greenhouse effect itself isn't the villain here. Not at all. It's actually a good thing. Think of it like a cozy blanket for the planet. Certain gases in our atmosphere trap just enough of the sun's heat to keep Earth warm enough for all of us to live here. I mean, without it, the average temperature on Earth would be a ridiculously cold -18 degrees Celsius. The greenhouse effect brings that up to a nice, livable 15 degrees. So what's the problem? Well, human activity has basically been piling more and more blankets on, and now the planet is starting to seriously overheat. Which brings us to this number, 5.8 degrees Celsius. This is the high-end projection from the IPCC, that's the UN's body of climate experts, for how much the global temperature could rise by 2100. A change that fast would be a massive shock to ecosystems that have been pretty stable for the last 10,000 years. So what does a planetary fever actually look like? What are the symptoms? We're looking at sea levels potentially rising by up to a whole meter, which would threaten coastal communities all over the world. We'd also see a much more chaotic water cycle, causing extreme floods and droughts, major disruptions to our food supply, and even the spread of diseases like malaria and dengue into new places. So, faced with all these warning signs, what was the prescribed treatment? Well, back in 1992, the global community got together and came up with a plan, the United Nations Framework Convention on Climate Change, or UNFCCC for short. The main goal was to stabilize greenhouse gases and stop ourselves from dangerously interfering with the climate. All right, on to our second diagnosis. We're shifting from the planet's warming blanket to its protective shield, the ozone layer. Way up in the stratosphere, there's this thin layer of ozone gas that acts like our planet's own personal sunscreen. It's an absolutely vital shield, absorbing nearly all of the sun's most damaging ultraviolet radiation, specifically the UVB rays. But in the 20th century, we found a huge problem. Man-made chemicals, called chlorofluorocarbons, or CFCs, they were used in everything from refrigerators to spray cans, were drifting up into the stratosphere. And once they got up there, they acted like little chemical Pac-Man, literally eating away at our protective ozone shield. And the symptoms of this weakened shield were really severe. With more UVB radiation hitting the surface, the risk of skin cancer and cataracts in humans went way up. But the damage didn't stop there. It harmed plants, it disrupted entire aquatic food chains, and it even caused materials like plastics to break down faster. But here's where the story takes a really hopeful turn, and it shows what's possible when the world acts together. In 1987, because the science was so clear and we had other options, nations signed the Montreal Protocol to get rid of these harmful chemicals. By 2010, the most dangerous ones were gone. And by 2018, science confirmed the treatment was working. The patient was healing. And this really puts the recovery into perspective, a measurable increase of 1 to 3% every decade since the year 2000. It's a slow but steady recovery, and it's just powerful proof of successful global cooperation. Finally, let's look at our third diagnosis. This is a condition that literally corrodes our world from the sky down. We're talking about acid rain. It's interesting, all rain is naturally a little bit acidic. Carbon dioxide in the air takes care of that. But what we call acid rain is totally different. It's rain or snow or fog that has become much more acidic, all because of industrial pollution. So here's how it's made. The process starts when we burn fossil fuels, which releases sulfur dioxide and nitrogen oxides. These gases travel high up into the atmosphere, where they react with water and oxygen, and they form sulfuric and nitric acid. This potent mixture then falls right back down to Earth as acid rain.
And the symptoms are so widespread and destructive. Acid rain leaches vital nutrients from the soil, damaging forests. It can turn entire lakes so acidic that fish just can't survive. It can contribute to breathing problems in people. And remember that crumbling monument from our opening question? This is why. It actually corrodes stone and metal, erasing pieces of our history.
So after diagnosing these three huge atmospheric conditions, what's the overall prognosis? What does the global treatment plan even look like? Here's a quick summary of our planetary checkup. For climate change, the culprit is greenhouse gases, and the treatment plan is the UNFCCC. For ozone depletion, caused by CFCs, the global response was the incredibly successful Montreal Protocol. And for acid rain, caused by sulfur dioxide and nitrogen oxides, we rely on international agreements to limit pollution that crosses borders. And that brings us to the final thought. The healing of the ozone layer isn't just good news. It's a blueprint. It shows that when we identify a clear threat and we actually act together as a planet, we can reverse the damage. It proves a positive outcome is possible. So the question this leaves us with is, for the immense challenge of climate change, how will we apply that lesson and write our own success story for the planet's recovery?